Solution to quadratic equations. The solution to a quadratic equation ax squared, the solution to the quadratic equation ax squared plus bx plus c equals to 0 are called the roots or zeros. The solution sets. So if here we have a sketch of the different curves of a quadratic function, in one situation we could have our curve. Here's the x-axis, cutting the x-axis at 2 points. Well, it could be in such a way that the curve just touches the x-axis, or our curve does not touch the x-axis at all. In that case, we talk of imaginary roots. So the roots here are real and distinct. Here we have repeated roots. Here, no real roots, not real. Such an equation has complex roots. In other cases, we could have an inverted parabola. So our parabola could go like this and cut x-axis at specific points. Here we have distinct roots. Or it could just touch the x-axis. Or likewise, you could have it never touching the x-axis. So here we have imaginary roots. If we are given a quadratic function and asked to look for the nature of the roots, what do? We have to use what we call the discriminant. This discriminant is equal to b squared minus 4ac. So if our discriminant is equal to 0, we'll have here repeated roots. The roots are real and repeated. If our discriminant greater than 0, we have distinct roots, real and distinct. But if our discriminant b squared minus 4ac is less than 0, we have complex roots. So let's take this example here. X squared minus 2x plus 3 is equal to 0. We compare this to our general equation ax squared plus bx plus c equals to 0. What is our a? A is equals to 1, b is equals to minus 2, and c is equals to 3. Now, what is b squared minus 4ac? We'll have minus 2 all squared minus 4, what is a? 1 times 3. This is 4 minus 12, which gives us minus 8. So our discriminant is less than 0. In this situation, our roots here are imaginary because the discriminant is less than 0. So we are dealing with a situation where our parabola does not touch the x-axis. Let's now look at these two examples. If I am given x squared plus 6x plus 9 is equal to 0, and p squared minus 2p plus 3 is equal to 0. What is the nature of the roots in these quadratic equations? I take the first one, b squared minus 4ac is my discriminant. So now, what is the discriminant here? I'll have here b squared, that is 6. 6 squared minus 4, a is 1 times 9. So this is 36 minus 4 times 9 gives me 36 equals 0. So this tells me that I'm dealing with repeated roots. Let's take the second one. I have p squared minus 2p plus 3. So what is our discriminant there? Minus b, which is b squared, which is minus 2, all square minus 4a. What is a there? 1. What is c? 3. This is 4 minus 12, which gives us minus 8. So in this equation, we have imaginary roots. Okay, let's say this is our equation where p squared minus 2p minus 3 is equals to 0. Now, what will be our b squared minus 4ac? That will have minus 2 all square minus 4 times 1 times minus 3. This is 4 times, this is 4. Minus 4 times minus 3 gives us plus 12. This is 16. And 16 is greater than 0. In this case, our roots are real and distinct. Use the discriminant to find out the nature of the roots in the following quadratic equations. There are two known methods for solving a quadratic equation. These are the algebraic method and the graphical method. We shall start with the algebraic method. Given the algebraic expression ax squared plus bx plus c, we said this expression is quadratic because the highest power of the unknown is 2, which therefore means that it has at least 2 roots, which we can say are x minus alpha factor of x minus beta, where alpha and beta are real numbers. If we are given x squared minus 6x plus 5 to factorize, what do? So here, if we consider our roots to be alpha and beta, we shall have the product of roots and the sum of roots. The product of roots, is given by AC, while the sum is given by B. So now, if I take this expression, this is x squared minus 6x plus 5. I compare it to my general quadratic function ax squared plus bx plus c. I find here that a is equal to 1, b is equal to minus 6, and c is equal to 5. What is my product of roots? Product of roots is AC. Product is equals to AC, that is 1 times 5, which gives me 5, and sum is equal to B. My B there is minus 6. So what do I ask myself? Which two numbers will I multiply to give me 5, and when added will give me minus 6? Those two numbers are minus 5 and minus 1. So if I say minus 5 times minus 1 gives me 5, minus 5 plus minus 1 gives me minus 6. What do I do with these two numbers? I'll use these two numbers to turn the quadratic function with 3 terms into one that has 4 terms. So this will give me, in the place of minus 6x, I'll write minus 5x minus x. So this will be x squared minus 5x minus x plus 5. and then factorize these two. So this will be x is common there. This will give me x minus 5. 1 is common, minus 1, x minus 5. So the factor in bracket is repeating. I write it once. X minus 5 factor of x minus 1. So we have factorized this quadratic function. How do we factorize quadratic functions? So we know that a quadratic function has at least two roots. So if you have f of x is equal to ax squared plus bx plus c. Here we can have at most two factors, which we call x minus alpha and x minus beta, where alpha and beta are real numbers. If you are given this function x squared minus 6x plus 5 to factorize, here I compare this to general function, quadratic function, ax squared plus bx plus c. A there is 1, my b is minus 6, and c there is 5. So an easy procedure to factorize a quadratic function is to look for the product of roots and the sum of roots. The product of roots is equals to a times c, while the sum of roots is equals to b. So looking at this my equation, I find here that my product of roots a times c is equals to 5, and the sum of roots b is equals to minus 6. What do I do with this sum and product? I ask myself, what two numbers will I multiply that will give me 5, and when those numbers are added will give me minus 6? So let me look at the multiples of 5. I can have 1, 5. So 1 times 5 gives me 5, or I will have minus 1 and minus 5. So minus 1 times minus 5 gives me 5. I look among these two factors here, these two sets, I see here that minus 1 plus minus 5 gives me minus 6. So this is the set I'll use. Now what do I do with these two numbers? This quadratic function has three terms. I'll use these factors to expand it into 4 terms. So this will give me x squared. I'll say minus x as minus 1 minus x minus 5x plus 5. I'll factorize the first two. After that, I factorize the next two. What is common between these first two terms? X is common. It goes the x there minus 1. Minus 5x plus 5. Minus 5 is common. I'll have the x minus 1. So what is in brackets should be the same. Now, x minus 1 occurs twice. I write it minus x minus 1 factor of is according to the distributive property. Yeah, x minus 5. So I have factorized this quadratic function. Let's look at another example. Factorize f of x is equals to 2x squared minus 5x plus 2. Now let me look at product of roots is equals to ac, and sum of roots is equals to b. So what is ac here? This is 2 times 2, which gives me 4. The product there is equals to minus 5. Ask myself, what two numbers can I multiply to give me 4, and when added will give me minus 5? Let me look at the factors of 4. I can have 2, 2, or minus 2, minus 2. So there's no way I can manipulate this set of numbers to give me 5. I look at another possibility. I can have 1, 4, or I could have minus 1, minus 4. If I look at these numbers here, 1 plus 4 does not give minus 5. If I take minus 1 minus 4 gives me minus 5. So I use this set. Now I expand this. This will give me 2x squared minus x minus 4x plus 2. This contains 3 terms. I've changed it to have 4 terms so that I can factorize. I'll factorize the first 2 here. What is common? X is common. I have 2x minus 1. Here, what is common? Minus 2 is common. I'll have 2x minus 1. This factor is repeating. I write it once. 2x minus 1 factor of x minus 2. That expression has been factorized. Let's try this one. 3s squared plus 10s minus 8. What is our product? AC is equals to 3 times minus 8 gives me minus 24. Sum of roots is equals to b, which is 10. Which two factors of minus 24 when added will give me 10? So I check and I'll see that I have there minus 12 and 2. So I see that I have 12 and minus 2. This will give me 3s squared plus 12s minus 2s minus 8. What is common between these first two terms? 3s is common. This will be s plus 4. What is common here? Minus 2 is common. S plus 4. S plus 4 is repeating, so I write it 1. S plus 4 factor of 3s minus 2.